Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is lexicographically smallest string after operations with the constraint. So we are given a string and then we are given an integer k, and then we need to find the string which has a minimum distance between this particular string, which is yes, and then we need to use only the k distances which is present as of now. So let us take this particular example where we have z and then b and then z, and then we need to return some particular string which will use this particular distance, and then it should be lexicographically smaller. Suppose let's say this particular string abcd till z, it will be like a circular. Suppose let's say if we take like this circle, then if we have a here and then b c d and then till z, after z there is going to be one more a, so we are going to take it as circle. So and then we need to use the distance between all the letters which is present. So the distance between a and c is going to be 2, and then the distance between a and d is going to be 3. So we are going to use that. Suppose let's say if I take this particular string, we need to return that. So for this particular string, if we want to get lexicographically smaller element, then we are going to consider a. So if I consider a, then the distance is going to be one distance from z to a. So we are going to decrease this k to 2, and then we are going to add as a. Now this is b, so we need to decrease this lexicographically smaller. So we'll change to a, so which is going to be from b to a. So this is going to be a, and then we will be decreasing k to 1, and then we are going to consider b. So for this particular b, we are going to consider a, and then we are going to decrease 0. So and then at last we do not have any k distance to change this particular z to either a or b or c or d. So we'll be having the same z, and then we'll be returning a and then z. So for this, let's say there is other elements which can be taken into consideration. Suppose let's say I have c and then I have k equal to 1. So suppose let's say I have c and then k equal to 1. So now I need to return this particular the string which is lexicographically smaller. So for this c, we can consider a b c d till z. So for this we are going to consider only a b, which why? Because this will be smaller letters compared to c. So if I use a, then the distance between the c and a is going to be 2, but as of now we have only k equal to 1, so we cannot use a. So we'll see b, whether we can use this particular b or not. The distance between b and c is going to be 1, so that's why we can use that. So we are going to have b b z, and then we are going to return this particular answer. So let us go through the code. So we'll be checking all the elements which are all the different characters which can be taken. So 0 means a, and then 25 means z. So we'll be considering all those. So we'll pick each character which is present in the string, and then we are going to pick each different characters like from a to z, and then we are going to calculate what is the distance between this particular string which is present as of now, and then the character which we need to change, which is going to be j. So let's say the distance between them is going to be two different distances. So if I take this particular example, then the distance between z and a is two distances, which is from here to here. That is from j plus 26 to this particular z, and then from j to which is 0 to till z. So these are two distances. Out of these two distances, we are going to consider only the minimum distance. So that's why we are going to say this is the minimum distance of these particular uh, character differences. Suppose if the difference is less than or equal to k, then we can decrease that particular k, and then we can assign this particular character with j and then plus a, and then at last we are going to return the answer. So for this, if we come to the time and space complexity, the time complexity is going to be 26 into big of n. Why? Because we are considering 26 different characters, and then we are going to go through each each and every character which is present in the string, which is of length n, and then the space complexity is going to be big of 1, and then yeah, big of 1. That's all for this video. Thanks for watching.